Hi, my name is Alan Offer, and today we're going to talk about the avionics of ICARUS. For those who haven't watched the first video, ICARUS is a HPR rocket that I launched on October 1st, 2022 in Italy. The rocket attained an apogee of 580 meters. And how do I know that? Thanks to the avionics. The avionics of Icarus is called GERONIMO. GERONIMO is inspired by the BBS flight computer Blip. So actually, what is an avionics? An avionics is an electronic device inside a spacecraft that control some part of the rocket. In this case, Geronimo is only passive in the rocket. Its objective is only to record flight data. But in the next rocket, it can also deploy the parachute at the apogee with pyrotechnical device. The brain of Geronimo is a Tensy 3.2. It's more powerful than an Arduino, but is clearly overkill for the project. Geronimo has two main sensors, the barometer MPL311A2 that record altitude and pressure, and the gyroscope GI521. Those sensors are doing okay. The next flight computer, I will change them. For recording data, Geronimo has a micro OSD card holder by Adafruit and a flash chip. Talking about the state indicator of the rocket, the first one is a 3-color LED that indicate the state of the rocket. And the second one is a buzz. It can help us knowing if the rocket is ready to launch when it is on the launch pad. So the power of Geronimo is controlled by a 12-volt battery. So now that we've seen all the components of Geronimo, let's talk about how I actually built this flight computer. So the first step to design a computer is to build the schematics. This is the schematic of Geronimo. So the purpose is to put all the components and to connect them with the right part. So at the center there is this central unit, so the Tensy 3.2. This is the brain of the computer. To power this computer we need an external battery. To do that we put two screw terminals. One for the battery and the second one is to put a switch. After passing into the switch it comes in the regulator. Indeed, the Tensy need only 5 volts and the battery is 12 volts. So we need to step down the current to 5 volts. Then this 5 volts powers the Tensy and all the sensor and a micro SD card. Gyroscope and the altimeter are connected with I2² protocol. On the other end, the two memory module, the flash chip and the SD card breakout, are both connected with SPI protocol. Moving on, we have the first state indicator here, a 3-color LED with an input of 3 volt. Those 3 branches are connected to the Tensy on the pin 16, 15 and 14. The second state indicator is the buzzer. The first lead of the buzzer is connected to the Tensy on the pin 6 and the second link is connected to ground. Looking here we can find the 4 pyro channels with the 4 MOSFETs and the 4 screw terminal connected to the first lead to 12 volt and the second one to this little circuit that put online or offline the pyro channels. Looking here at the 2 servos of the TVC. So one servo is connected, the first lead, the signal lead to the TVC Y and X, connected to the pin 3 and 4 of the Tensy. The power lead is connected to 5 volt and the ground is connected to ground. Finally, we can see here a voltage sensor, which is actually a voltage divider, to find out the voltage of the system. So this is the second part to our project, the PCB design. So actually what you have to do is to place all the components and trace routes between the parts. So actually this is a 2-layer PCB, which means we have the top layer, this red one, and this bottom layer. Consider this process as trying to connect 2 places without interfere with other routers and building. So looking at the top layer here, we can see the tendency right here, the barometer here, the IMU here, the SD holder right there, the flash chip right here. Here we can't see, but there is the buzzer here. This is the LED, the 4 power channels, the battery terminal, and the switch terminal. This is the voltage regulator and the 2 servo pins for the TVC. There's actually one more terminal for UART connection. Looking at a 3-modal representation, it gives something like that. So now that we've seen how I built this computer, let's talk about how you actually start up this avionics on the launchpad. Actually, we use this connector, which is epoxified in a part of the tube, and actually there's the computer. And when you want to start up the computer, you put the connector in the computer, and this part of the connector is actually plugged in with the rest of the tube, and the rocket fly like this. Well, that's it for today. In the next video, we're going to talk about the recovery system of the rocket. If you have any question about Geronimo, please write them down in the comments right below. Thank you very much for your attention, and I will see you in the next video.